Good morning. So in this video, I'm going to discuss the rate of entropy generation. So entropy generation is basically the same as delta S total in physical chemistry. So if you still remember your physical chemistry, basically this is the sum of the delta S of the system and the delta S of the surrounding. So let me share the PowerPoint. So this is our first slide is shows you the entropy balance for open system. So as you can see, we have four terms. The first one is the net rate of change in the entropy of the flowing streams. So basically, parang consider a tank. Tapos, there are several streams that can flow in and out of the tank. So you can have the input and the outputs. So basically, these streams contribute to the total entropy generated in the system. So this is the first term, the net rate of change in entropy of flowing streams. Tapos the second term is the time rate of change of entropy in the control volume. So in open system that is not steady state, that is not in steady state, the entropy in the control volume or in the tank is changing as time passes by. So the second term represents the change in entropy. And then the third term is time rate of change of entropy in surrounding. So basically, the third term is the delta S surrounding, the delta S surrounding that, So generally, ang assumption natin sa surrounding, kamukha din sa physical chemistry, the temperature is constant. So basically, later you will find out that this is just equal to Q divided by T. So the sum of all these three would be equal to the total rate of entropy generation, or SG dot. So in physical chemistry, we have only the delta S system. This is your delta S system. And then this is your delta S surrounding. So wala itong second term sa physical chemistry. Pero later on, when we consider only the steady state, the second term will also become equal to 0. Okay, so this is our equation. This is the delta S of the system. Basically, we have the equation in terms of rate. We have the generated entropy rate, SG dot. So that's why we need to multiply delta S with M dot. So may FS dito, this means flow stream. Because in this particular equation, we don't have only the entrance and exit streams. It's possible that you have several streams from 2 to 100 stream. This equation can still represent that kind of system. And then the second term, the DMS-CB. CB stands for control volume. So as I mentioned, control volume is your tank, in real life, So this is the change in entropy with respect to time and control volume. So pag nag-steady state, itong term na ito magiging 0 lang. And then the third term is the change in entropy of the surrounding. So generally, ang assumption natin that the entropy of the surrounding, the equation is reduced to Q divided by the surrounding temperature. Because the surrounding temperature in most of the cases is assumed to be constant. The temperature of the universe is constant. Even the heat that you withdraw from the surrounding or the heat you add to the surrounding is very large, still it will not significantly change the temperature of the surrounding. So we just simply solve a ds surrounding dt as equal to the negative Q divided by T surrounding. So we have here the negative sign kasi it enters the surrounding, pero it goes out of the system. So that's why we have the negative sign here. So when we replace the third term summation of Q divided by T surrounding, negative summation of Q divided by surrounding. The equation now becomes delta S dMSCB dt minus summation of Q divided by T surrounding is equals to S surrounding. And then this SG should be greater than or equal to 0. No? If the process will be possible, if the process is possible, it should be the S generated should be greater than or equal to 0. Okay, so if we're going to consider steady state, the second term would be equal to 0. And we simplify the equation to delta S m dot Fs minus summation of Q divided by T surrounding is equal to S generated, the rate of S generated. No? And this is equal or greater than 0. Okay, so if we're going to consider only one entrance and one exit, that's generally the case for industrial setup. You have a tank and then only one stream is getting into the tank and only one stream is getting out of the tank. No, you can multiply both sides of this equation by m dot 1 over m dot. So kasi nga una muna we have one entrance and one exit. So ang effect niyan mawawala na tong flow stream. Kasi dalawa na lang naman yung usually kasi pag pumapasok at saka lumalabas, halimbawa ito yung M1, tapos ito yung ating container, yung pumapasok yung M2, mass flow rate 1, mass flow rate 2. Usually ang nangyayari dyan, kung steady state tayo, hindi nagbabago yung height sa tangke, yung M.1 ay equal sa M.2. Tapos equal din lamang sila sa M. No? So pwede na natin tanggalin yung flow stream dito sa equation. So pag wala ng flow stream dito sa equation, all we need to do is multiply this by 1 divided by M. So dito sa term na to, mawawala yung M. No? Kasi you can factor this out kasi constant lang naman siya. So delta S na lang yung matitira sa first term. Dun sa second term naman, yung Q dot, pag dinivide nyo ng M dot, magiging Q na lang. No? Kasi di ba kung tandaan nyo pa yung equation natin, Q dot is equals to Q times M dot. So, dimensional analysis naman to. Halimbawa, joules per second yung Q dot. Yun namang joules, halimbawa, joules per kilogram. Tapos yung M dot, kilogram per second. So, as you can see, magka-cancel out yung to. And you will have the Q dot equation. So pag dinivide yung yung Q dot ng M dot, you will have Q. Tapos yung SG, ganun din yung rate ng entropy generation pag dinivide niyo ng M dot, you will have this delta S minus summation of Q divided by T is equals to SG. This should be greater than or equal to 0. So ito yung gagamitin nating equation to solve our sample problem. So this is example 5.5. In a steady flow process, 1 mole per second of air at 6 sorry. Let's proceed to example 5.6. mas simple ito. So example 5.6. An inventor claims to have devised a process. Usually ito yung application ng pagka-calculate ng S generated. Ginagamit ito sa patent investigation. So pag halimbawa merong nag-propose or merong nag-submit ng invention sa patent office. So ang unang-unang nilang chine-check yung second law of thermodynamics. And then to check the second law of thermodynamics, kung nasusunod niya ba yung second law of thermodynamics, dapat yung kanyang SG generated, yung rate of SG generated o kanyang SG, dapat positive or zero. Pero zero, actually imposible na rin yun kasi reversible yung process. So dapat positive yung SG. Doon ito ginagamit. So the process only uses saturated steam at 100 degrees Celsius. And which by a complicated series of steps makes heat continuously available at a temperature of 200 degrees Celsius, where 2,000 kilojoules of energy as heat is liberated for every kilogram of steam taken into the process. Show whether or not this process is possible. So to give this process the most favorable condition, assume cooling water available in unlimited quantity at temperature of 0 degrees Celsius. Tapos sa baba, meron tayong value ng entropy, S1, at saka enthalpy, H1. Ano? So galing ito sa steam table. So kinonsider natin yung saturated steam at 100 degrees Celsius. Ano? So later, mag-aaral tayo kung paano kumuha ng mga ganitong value sa steam table. I hope meron na kayong steam table. Ano? Siguro yung mga susunod na video, tuturuan ko na kayong gumamit ng steam table. Sa chapter 6, tuturuan ko na kayong gagamit na tayo ng steam table. Okay, so this is steam. Enters the apparatus. Ito yung invention na inaano natin. Nag-i-investigate tayo. Ano? Tapos, ang claim ng inventor, it can deliver 2,000 kilojoules at 200 degrees Celsius. No? Tapos, i-assume natin for investigation processes, ano, na yung steam, magiging ano siya, liquid water at 0 degrees Celsius. So, ang liquid water at 0 degrees Celsius, ano yan? Reference point. So, pag reference point, yung enthalpy niya, 0, pati yung entropy niya, 0. Okay? So, that's why we have H2 and S2 value given. Ano? Okay? So in order to solve this problem, we'll simply use yung ating equation na dinerive kanina. Ano? It's basically SG is equals to delta S minus summation of Q divided by surrounding temperature, Ts, or T sigma. Ano? So let's just substitute the given. Yung delta S na to, S final minus S initial lang yan. So ito yung S final. Ito yung S final. Entropy final. Ito yung S initial. Ano? So ang mangyayari dyan sa delta S nyo is basically 0 minus ito, negative, positive 7.3554. Tapos ang unit niya, kilojoules per kilogram Kelvin. Kaya lang, we're using 1 kilogram of steam. So ito mawawala na itong kilogram. So kilojoules per kilogram na lang to. Ano? Tapos let's proceed to this term. Itong Q divided by T sub S. Ano? So yung una nating heat, yung lumalabas dito sa system, itong negative 2,000, tapos pumupunta siya dito sa 200 degrees Celsius. So ima-minus natin yan. Kung gusto nyo, i-solve nyo to separately. Pero I hope you can imagine that. So ima-minus natin to, itong 2,000 na to. So the first Q over T is minus, tapos minus 2,000. This is in kilojoules. Ano? Tapos i-divide natin ng temperature. Dapat ang temperature Kelvin. Ano? So the temperature is 200 degrees Celsius. Tapos mag-a-add tayo ng 273.50. Tapos again, we're going to subtract this. No, nahati kasi yung heat. Yung 2,000 pumunta dito. Pero as you can see, the total heat available from the steam is 2,676. Tapos kasi wala namang matitirang heat dito sa liquid water. 0 lang naman. Ano? Ito, 0 lang naman to. Pero ang total nyo ay 2,676. Tapos wala namang natira doon sa water. 0 na siya. So kung yung 2,000 pumunta dito sa hot reservoir, may matitira pa kayong 676. Meron pa ditong negative 676 kilojoules na pupunta dito sa 0 degrees Celsius. So ima-minus nyo rin yun, minus negative 676. This is negative kasi lumalabas siya dun sa apparatus natin, sa system natin. Ano? Tapos divide nyo ng temperature, yung temperature dito 0 degrees Celsius, so divided by 273. Okay? So this will become negative, negative, positive, negative, negative, positive. And then just use your calculator to find SG. Okay? So you should be able to solve negative 0.6536. Ano? So anong consequence pag negative? Negative 0.6536. Anong consequence pag negative? This is in kilojoules per Kelvin. Ano? Ito Kelvin to, di ba? Ito Kelvin din. Kaya kilojoules per Kelvin. So anong consequence pag ang SG ay negative? Ibig sabihin, the invention is not possible. No? So hindi ma-approve yung patent. Okay? Okay, so we'll end up this video. Ano? and then try to solve the exercise for S generated or the rate of entropy generated. So in the next video, we're going to discuss W loss and W idea. So see you in the next video.